Hi guys, I came up with a new topic, Explainable AI, and how it can be used in a hybrid classification model that integrates transformer and CNN for dementia classification. So here you can see the data for the dementia classification. We have four classes, that is mild, moderate, non-dementia and very mild dementia. So this data set we can able to download from the Kaggle itself. So once we download the data, we can able to unzip that one, then we can go for designing the model. So here we are doing the hybrid model, so we can initially we can able to design the transformer model. After that we can design the CNN. So this is the program for the hybrid model. Once we design the model, then the training is completed, we can go for the explainable AI, how we can able to explain the things, how we can take the decision based upon the feature maps and outcome of this model. So these are the library files we can able to import here. Once we loaded the files, we can design the CNN backbone. So first model is the CNN model. Here we have taken the ResNet 18, which is old model, but you can take any model, the recent one, anything, whatever you want. So after that we can able to design the transformer model. So here the first step is the transformer encoder. So once the transformer encoded, we declare the class, then the first step is the positional encoding and the transformer encoder and the multi-head attention and number of heads. So everything we can design here, then we can do the back propagation. So then totally the transformer CNN also we need to do the back propagation. So here we have done the uh, designing the transformer as well as the CNN model. Once that is completed, we can go for our loading our data also. So here we can take our data, how much data we need to take for the training and the validation and the loading data. Here we can load our data. Totally we can load all the data from these data sets. After that we can train our model. So this is the model for training. Here we can take both the model, which means the combination of the CNN as well as the transformer. Then we can set up the epoch and we can take the images and labels one by one. We can feed it to the optimizer, then back propagation it. So everything, then finally we can finding the training loss and training accuracy, we can able to print it. And this is the main function, we can load the data set path. So this is the data set for data and content and data. So then we can use the loading that we can load the data, then we can load the transformer model, then we can test our input data as well. So then finally we can able to plot the loss, training loss and training accuracy. So this is the total program for CNN and transformer. Here we need to check where it is, where we are combining both the CNN and transformer. So here we can see that one. So first one is the CNN backbone, which is coming from the ResNet, and that is given to the transformer encoder. So this is the hybrid one, and we are taking the picture maps from the CNN, then we have given it to the transformer model. So this is the hybrid one. So finally we can able to get the classification, loss and accuracy for both the models. So here you can see the model how we are designed. Initially the CNN backbone is here. After that we can able to see the transformer encoder here. So initially this is for CNN, then this is for the transformer model. So once we design the model, we can able to train it. So we have set the epoch as here 20. So it is running on up to epoch number 20. So we got some loss value and accuracy. Finally we can able to display the loss plot and accuracy plot. So this is what how we designing and training the model. So now we got the model. So once we get the model, we need to check how the model performing a different input data, and which cases what are the parameters or what are the The activation maps is helps to identify helps to differentiate these kind of different kind of dementia. That's we need to know. So for that we are going to explain use the explainable AI. So it's explainable. It shows where it is changed from the data to data or image to image. Everything we can able to see. So for that we need to design all those things. So original image and how the transformer tokens looks like and how the gradients looks like and the Grad-CAM how it looks like, how the feature maps looks like, the first layer, second layer, third layer feature, everything we can able to see here. So right now if I run the data means if I run this program I can able to get the model. Once the model trained we can able to use the model and we can check out the intermediate feature maps and Grad-CAM and we can able to see what internally happened, how it differentiate the different data, so everything. So here I have already trained the model right now. Now we are coming to the explainable AI section. So here you can when we run this program we can see multiple images here. So for example, so here I have given the test image. So I have taken from that moderate dementia. So we'll see these figures initially. So this is the original image and this is the token from the transformer model. Then this is the integrated gradients. This is the Grad-CAM layer. And the second row is the feature map for different layers. Layers 1, 32 channels, layers 2, layer 3, layer 4 feature maps. The final one is the raw token map and raw integrated gradients and raw Grad-CAM, which means we are not overlapping with the original image. So we will see how it's different, how we can able to differentiate between this token and integrated gradients. So for example, in the token proxy overlay, this one second figure means, so you can see the multiple images, multiple colors here, right? So here the highlighted reddish areas means most activated spatial region, which means it comes under the hybrid CNN. So wherever the red area is there, those are the areas are mostly activated. If you see the integrated gradient means, so this area here you can see the little color variations here. This area is the most influential area, which means these are the part only mostly influenced the image to take a decision based upon this area. So these are the areas most influential area. This is the most activated area, and third one is the Grad-CAM. So Grad-CAM, what it's showing me, this heat map showing the discriminative region, how the area, how it's changing from the one class to another class, those things. So these are the three important explainable AI representation which can able to understand how it is taking a decision for a particular image. So right now I have given this image and we can able to see the how the activation spread over the image and which are the influential area, which are the differential area. So according to that one the system will identify. So suppose if I am giving another image, there also we can able to see the activation maps and the influential area and the differential area in the different places. So the second row, as I told you, this is the layer maps, how it's each and every feature maps from the CNN, how the feature is varying. And the third row is the raw token. That is it's a raw token is nothing but it is outcome of that hybrid model, where the red area is present most activated area, and the second image is the raw IG is the integrated. So that is the part where most of the influential area, those color areas influential area. So this is the raw Grad-CAM. This is the differential area where we can able to differentiate from the one class to another class. So if we give multiple images like this, we can able to see the difference of these activations. From that we can able to identify, can it's showing, it is explaining us how it's we are the model is taking that activations and influential area and gradients, everything. Suppose I am giving the another image, so I am taking from this very mild dementia, so we can see the difference also. Copy path I have given it here. So right now I just ran this model. So here you can see, so for this very mild dementia, but the result is not right. But we can see this is the activation, most activation. The second one is the influential area. Third one is the differential area. So here also you can see the raw maps, the original one, which means it's not overlapping with the original image. So these are the things we can able to understand by using the explainable AI. We can see what is happening inside as well. So according to that, we can able to see the difference of how the system is making the decision from one image to another image and one class to another class. So all those kind of information we can able to see, and we can able to justify also. In previously we can't able to see what is going on inside. Right now we can able to see what is going inside everything. We can see by our side, and we can also able to differentiate. So this is what explainable behavior, like that we can see all those intermediate layer separately. We can able to see CNN transformer, everything. So these are the four important things. The token, that means the outcome of the hybrid model, this one, integrated gradients and Grad-CAM. So I hope this one you can able to understand. So for that, first we need to design the model and train it. Once we train the model, we can take the model and we can get this kind of Grad-CAM and gradient and the token overlay, everything, to differentiate the different kind of classes. Yeah, I hope you understood. Likewise, you can try for another data set also. Right now, I have taken this dementia data set. Like that, you can take any application for any multi-class problems. You can use it and you can check it how it's varying from one class to another class. Yeah, that's all. I think you hope you understand everything. If anything means, you can ask me and you can contact us. Thank you. Thanks for watching.